All right, so today's lesson is about the difference between rational and irrational numbers, okay? So some of you may have heard these terms before, rational and irrational, but just want to make sure we clarify because as we continue on in our mathematical journey, you're going to be hearing these terms quite a bit, and they'll have more significant meaning as you go on. But I just want to introduce them to you right now, and let's talk about the differences between them, okay? So again, we have rational and we have irrational. Okay. When I think of those words, this is the first thing that comes to my mind. So rational, that means you're like calm and you're normal. There's nothing weird about you. It's just kind of like you're pretty plain. You have a good level head on your shoulders, and things are not that bad. So when I think rational, I think of just normal-ish numbers. Okay. So for example, a normal-ish number would be an integer. So an integer is any number, negative or positive, but it's not a decimal. Okay, so any number, negative or positive. So negative 7 would be rational. 5 is rational. Negative 135 is rational. Okay, 0 is also rational. So just be aware of that. So an example of an irrational integer would be having something like negative 5.34762 and you'll notice that if I kept going that I wouldn't have any pattern, right? So typically irrational numbers are decimals that that continue, so they're decimals that continue with no pattern or ending. Okay. So the counterexample to this, a rational decimal would, so these are integers, by the way. Let's write that. So integers. Okay. So a rational decimal would be something like if I had 6.25, and that was it. If it ends, then it is a rational number, meaning the decimal just stops at a certain place. So if I had like negative 7.1253 and that was it, then that would also be a rational number. Okay? So let's write a note here. So a rational decimal is a number that stops. So a number that stops. It doesn't just keep going and keep repeating itself. Okay. Another example of a rational decimal would be if I had something like 13.3333. Okay. Or we can write it like this, 13.3. Okay. If it repeats, meaning it has the same pattern over and over and over again, that would also be a rational example. So the only time it's irrational if it continues with no pattern or ending. Okay, that would be irrational. A common irrational choice that usually we think of would be pi. Okay, pi is an irrational number because if you write it out, it would be 3.141592653, so on and so on. But you'll notice that it doesn't have any repeats and it will just go on forever. So pi is a classic decimal that is irrational. Okay, just some other common ways that we have rational or irrational. A rational number would be a number that is in a fraction. Okay, and actually that's where we get the term rational number because it's a fraction. Okay, so if I had something like 3 over 5, right? So 3 over 5, if we made it a decimal, would be 0.6. So usually anything that we can make into a fraction, or if it is a fraction, is a rational number because it's been rationalized, meaning the fraction is actually there. Okay, so 3 over 5 would be an example. Here would be an example of it being irrational. If I had something like the square root of 3 over 5. Okay, we're going to talk about this next, but if a fraction has a square root inside of it, and it's not a perfect square, so if you took the square root of 3, you would get a decimal like 1.7. That is an irrational number. Okay, so like I just mentioned, if I have a perfect square, so like the square root of 4, equals 2. That is a rational number because it's a perfect square and it comes out nice. But an irrational number would be like the square root of 5, right? If I typed that into a calculator, that would give me a decimal that doesn't repeat and doesn't end. So the square root of 5, again, basically any perfect square, so any perfect square is a rational number. Okay? And essentially that's it. Just the big things here are, again, decimals. If the big one is decimals that stop or have a repeating pattern, those are rational. But decimals that don't, like pi or the first example I did there, are irrational. Square roots that don't that aren't perfect squares, like square root of 5 or the square root of 13, those are irrational. And the square root of 3 over 5, again, a fraction that has a radical in it or square root in it is also irrational. So take a look at this list. Hopefully this helps, and we'll talk more about it tomorrow in class.